Welcome to Pomodoro Joe for Tuesday, May 30th, 2023. Today we're doing LeetCode problem 705, Design HashSet. This is an easy problem. Design a hash set without using any built-in hash table libraries. All right, so that means we're not allowed to use a set or a dictionary. Sometimes in other languages this might be called maps. Implement myHashSet class. Void add key inserts the value key into the hash set. Bool contains key returns whether the value key exists in the hash set or not. Void remove key, remove the value key in the hash set. If key does not exist in the hash set, do nothing. All right, so this seems pretty straightforward. We can do this easy ways to hard ways. There's like a spectrum of ways we can do this. So we'll start with the easy way. So just taking a look at our constraints here, our key will be anywhere between 0 and 10 to the 6th. All right. That is actually very useful. So with that, we'll put 25 minutes on the Pomodoro timer and we will get started. So I'm going to do this the easiest way that I can think of at first. And then if there's time, we'll go through some of the more difficult ways that are probably more efficient. All right, so we know that the key is between 0 and 10 to the 5th. Or no, sorry, 10 to the 6th. So we'll just pre-allocate an entire array that goes from 0 to 10 to the 6th plus 1. So we'll do that here. So self, we'll just call it storage. That will be an array. And let's see, I'll fill it with zeros times 10 to the 5th. So let's see, that's 10 to the 1st, 2nd, 3rd, 4th, 5th, 6th. But we need to add 1 because this key can go to 10 to the 6th, including 10 to the 6th. This is a zero indexed array, so we have to go one further to make sure that we include all the values that could be our key. So my plan here is just to have some storage. It's filled with zeros, meaning we don't have that key. We have all of the keys. Our key will be the index into this array. So we have all of the possible keys and they're set to 0 already. So that's pretty much it. Now we go down in our add, we just say self storage at this key, because our key will map directly to the index into our storage. We'll just set that equal to 1. All right, then for remove, we'll just do the opposite, self.storage. For this key, we'll set it equal to 0. And then if it contains the key, we'll just return self.storage. At this key, if it's equal to 1, then we have this key in our storage. If it's equal to 0, we don't. So we just have to check if it's equal to 1. All right, and I think that should do it. Let's give it a shot. All right, passes the initial test. Let's see how we do. All right, and we pass. So this one beats 35% for runtime and only 5% for memory because we're already allocating pretty much all the memory we'll possibly need. So we're not going to do so well on memory. All right, so let's see. Let's try something a little bit more difficult. So one thing we could do, well, let's just give this a try. We could actually set this to a Boolean. Instead of storing an integer, we could store a Boolean, which might save us a little bit of memory. But in Python, I don't think the Booleans actually map to a single bit, so it won't really save us that much memory. But we could try this. Set this equal to false to start with. Then for here, if we set it, we'll set it to true. And if we remove it, we'll set it to false. And then we can just return the value at that key. We don't even need to compare it to anything. So this might save us a tiny little bit, but I'm skeptical. And we don't really save anything. 34% runtime, 5% memory. We actually lose a little bit on our runtime, so that doesn't really save us that much. All right, now we'll jump into a little bit more complicated solution. This solution is going to use something, actually I don't remember the name for this. Essentially it's a, what do they call this? A bucket sort. It's similar, if you're familiar with a bucket sort, this will be similar to a bucket sort. But essentially we'll allocate some storage, but not the entire storage. We'll allocate buckets. And by what I mean by that is we'll have an array. Each array index represents not just one value, it can represent a number of values. So for instance, our 0 indexed value here could represent all the numbers between 1 and 100. Then internally, instead of having just a single value, we'll have another array. So we can index into the right bucket and then find the value within that bucket. It saves us a little bit of searching. Actually, before we do that, maybe we should try something even simpler. We'll just have a storage which has an empty array to start with. Then we'll just add our value to the array. Then we can search for the value in the array and remove it if we need to, or we can just search for the value in the array and return true or false if it's in the array. So this is going to be somewhere in between our initial pre-allocated block here and our possible bucket sort type solution. All right, so in this one, so our storage, let's see, we'll just say append the key. So we're adding the key to this list. Now on the remove, we'll have to remove that key. And then return, instead of doing an index into the key, we'll have to say return key in self.storage. So for this one, it does depend on searching. So we'll have storage, which is just an array. Then we'll append the key to add it, but only if the key, actually that might result in duplicates, so we don't want to do that. So we need to actually check if the key is not in our storage. So if the key is not in the storage, then we can append the key. Otherwise we might end up with duplicates, so we do have to check first. And then we also have to do this here. If the key is in storage, then we can remove the key. And then finally down here, we just return true or false if the key is in the storage. All right, let's see if this works. So this will probably be slower only because these searches are going to be a little bit slow. All right, so this does work. We do better on memory. We beat 45% for memory, but we do much worse on our runtime, only beating 23% for runtime. Okay, so now we have this in-between solution. This is where we'll actually create these buckets. So we'll actually have an array of arrays. So each index in the array will represent a bucket of values. That bucket of values will be anywhere between, well, we can decide, I guess. It could be 1, it could be 1 to 100, 1 to 1,000. It's whatever we decide to choose. So let's do this. Let's have a storage size. We'll set it to 1,000. We can play around with these numbers later too. So in this case, we'll have empty arrays for blank in range self.storage size. So what we're doing here, this might be a little bit more complicated than the easy type problem that you're expecting, so try to follow along if you can. If you can't, that's okay, it's no big deal. So we'll be creating an array that's an array of arrays, and we'll have empty arrays to start with, and we'll have essentially 1,000 of them. All right, actually, because we're doing storage size of 1,000, we need to go to storage size +1 because the range is non-inclusive. Okay, let's also create a helper function out here. So we'll need two types of keys. We'll need the primary key or the bucket key, and then we'll need the secondary key, which is where inside of our bucket is this particular key. All right, so let's have some function here. It's like get keys. So given our key from our add, we'll return our bucket key. Let's see. And that will be essentially our storage size. No, that will be our key doing an integer divide by our storage size. So if our key was, let's say, 1,010, then when we divide by 1,000, we'll get an index of 1. 1,010 divided by integer divide by 1,000, there's 1. So this will give us a bucket key of 1, which will be our index into our storage. So we'll look at the bucket at index 1. Now, once we're inside that bucket, we need to find out if the rest of the key exists in that bucket. So we'll have the, what will we call this? I'll call it the secondary key. I don't know what it's really called. And that's going to be this key, but now we'll do a mod by self.storage size. So what the mod will do, this modulo, it will essentially drop all of the numbers above the thousandths place and give us all of the numbers below the thousandths place. So if this was like 1010, when we do this mod, we'll just get 10. It's the remainder of dividing this by 1000. And then we do need to return our keys here. So we'll return both the primary and secondary key as a tuple. Again, this is more complicated than an easy problem, so if you're not following along, it's totally okay. All right, then in here, instead of looking for our key directly, we need to do a little bit more work. We'll have to get our primary and secondary keys, or our bucket key and secondary key, so I'll do that here. All right, so we have a bucket key and a secondary key. So we have to get the bucket, and that's going to be our self.storage for this bucket key. And then we need to add this value into that bucket. Yeah, this is sort of like our second solution, where we'll check to see if it's already in there, and then we'll only add it if it's not already in there. Okay, so if the secondary key is not already in this bucket, we will add it to the bucket. Then same thing with this remove. We will do the same, grabbing our bucket. So we'll get our bucket key and we'll get the bucket we're looking for. Then instead of looking for the key in storage, we'll look for it in this bucket. And if it's not in the bucket, or if it is in the bucket, then we'll remove it. And then finally, at this last one, kind of do the same thing. Grab our key, grab the bucket, and we just return whether or not the key is in that bucket. All right, let's give this a shot. All right, this is a class. So we have to do self.getKey, and we have to, all right, that's my fault. Because this is a class, we need to add the self as our first argument, and we need to call it using self.getKey. Try this again. Typo. Wouldn't be a Pomodoro Joe video without some typos. What just did I do? All right. These need to be secondary keys as well. These have to be self. Oh my goodness, I am just totally messing this up. Okay, try this one more time. Okay, so this works. Let's submit this and see if we can make any improvements on our initial solution. This should be secondary key. Man. Okay. Thanks for bearing with me with that. Yes, we do pass, and we beat 54% for runtime and 45% for memory. So we get a memory solution that's much closer to our second solution, 45% and 45%, but we get a runtime solution that's closer to our first solution. Actually, it's even better than our first solution. So let's see what people are doing to do better than this. And I'm guessing they're cheating. I shouldn't say cheating. So let's see, this first one is nuts. It's using the user out, it's reading the file directly. Okay, so this one we're going to ignore. This is some LeetCode craziness where it's actually reading the input directly and it's using sets. So this is not really a fair comparison. All right, next. This one is using a set, which is explicitly against the rules, so that one doesn't count. What's next? This one is also using a set, which is against the rules. All right. And this one is using very similar to our first solution. Looks like, oh no, it's actually very similar to our second solution. They're creating this key. Okay. Yeah, so this is very similar to our second solution. All right, so, and it looks like we are in line with that one. So it looks like this is kind of the best we're going to do unless we break the rules and use a set. So in that case, I am totally okay with getting a 54% for our runtime because that is the best that we can do, most likely without using the built-in set. So with that, I will bid you adieu. All right, hope you enjoyed this. Hope you learned something. Hope you had fun. Hope you can go out and write better code.